Okie dokie. So, the Sumerian game. First of all, I'd like a raise of hands for everyone that's heard or played the Sumerian game, and I'll know instantly if it's true or not. Wow, you are none of you are liars. I am very happy about that because it's very hard to have known about the Sumerian game because it wasn't until the late 2019 that this mystery kind of emerged on the internet because there was a guy. I can't exactly remember his name right now, but he's a game historian, and he announced on Twitter that there is this thing called the Sumerian Game, and it's been hidden from public domain since like the 1960s, and it's been a vital step in the history of game development, especially in the educational sector, and people got like, or at least 20 people on the internet got like, oh, super excited about it. Either way, the Sumerian Game is something I'm going to be describing as I go, what it's about, what the gameplay is. But what you need to know at first is that the origin story is kind of it's a hybrid between big technology, the thirst for knowledge, and also the fact that women just recently, during this time in the 1960s, got officially the right to vote. So the women liberation movement, the kind of inclusion of more women into the work market and into technology was a huge stepping stone in the right direction for women to be able to contribute more into the development of software and hardware and that kind of stuff. So here's actually the bill, the act from back in whenever it was. I wish I knew when it was. I should have maybe checked that. 1964, it says, stamped on the side there. And that, at the same time, there was a little happening inside of a big international corporation called IBM. I bet you guys have probably heard of IBM before. Maybe some of you even have computers that have been created by IBM. And there was a guy inside of IBM that decided that maybe computer technology would be a good idea to start implementing into the educational space. Like maybe we could test out some cool things in education and see if computers can contribute to it. So, after a lot of ums and ifs and ums, the federal government decided to give $103,824 as a federal grant to the study of simulations in education. Now, I don't know about you guys, but that seems like an oddly specific number. I have no idea how it ended up being exactly $103,824. But this is an actual newspaper cutout from back in 1964, 1965, I believe. And in here, if you read through this, you'll see that, okay, this guy wants us to use computer technology to teach some kind of, I don't know, whatever it is. It could be economics, history, mathematics, using computer technology. And that they're going to get a bunch of teachers, exceptional types of teachers, to help in the development of this. And right there, in the little yellow box, as you can see on the screen, is the name Mrs. Mabel Addis. Now, she's kind of the main character in this story. Mabel Addis was a school teacher back in the 1950s, 60s, 70s, who had an extensive education. She had a minor in psychology and a major in history, and she also touched on economics during her studies. And during her time as a preschool, not a preschool teacher, but a primary school teacher, she wrote history books. She was really involved in a lot of things. So I guess one of the reasons why IBM decided to cooperate with her, among other people, was because she was quite an exceptional person to begin with. And she was given the responsibility to design this game, this Sumerian game. Now, the premise of the Sumerian game, according to IBM, what they wanted to achieve was they wanted to create a game that both took history into account, like immersive history lesson, but also taught kids how to use economical systems to determine different parameters. So, for example, if you're the ruler of Sumeria, this guy called Ludugu or Luduga, which this is not Luduga. This is a picture of some other guy, and I'm not even sure if Luduga is a real person. But Luduga, if you're him, and you're asked how you're supposed to delegate, or how much of the corn you're supposed to give to your people, how much you're supposed to save, how much you're supposed to put into the next year's crops, how would you determine that using economical science? How would you determine that using formula and good old common sense? That was what the game was supposed to be about. So she got to work, and she decided to divide this game into three parts. First part was over the course of about 60 years, and you're Luduga the first. And all the decisions you have to make is about harvest and distribution. So how much corn are you supposed to be growing? How much are you supposed to be giving to your fellow man or your subordinates? And how much are you going to be feeding yourself, and so on and so forth. And then each step, Luduga number 2, makes it a little bit harder. Then you get to use some of the surplus or the extra corn that you produce to develop things like crafts. So you're actually creating some kind of an economy. You are making pottery, maybe you're doing woodwork, all sorts of other things that will accelerate technology. And then in the third phase, you introduce trade and colonization and war to make things more complicated. So in the third phase was when it started to look more like modern types of strategy games, like you've probably played before. So let's say modern, Total War or Civilizations or something like that. The only thing that was quite different was that these old games were not graphic friendly. There were no graphics, they were just text, and they wanted to spice this up a little bit, and I'll come back to that a little later. Now, so this is, I was going to say famous intro line, but it wasn't famous until last year. This was what the game started with. We have harvested 5,000 bushels of grain to take care of 500 people. How much of this grain shall we set aside for the next season's planting, and how much will be stored in the warehouse? And then depending on what you chose there, you would have consequences. So that was the basic design of the game. I wanted to actually show you real quick something pretty cool, because back in the late 1960s, there was a report written from this experiment. Let's see if I can find the beginning of this report. Here it is. That took 3 games that was tested in these simulations, among which was the Sumerian Game, and they wrote out the entire premise of the game in almost like a scientific report, detailing how it was designed, what kind of things was put into it, so that people could, if they wanted to make a game that was like the Sumerian Game, they could try to recreate it themselves. And in here you have things like, random disasters. So every round that you would play, they would introduce some random disaster, and then describing how that random disaster would be implemented. And then they're doing it with some random numbers in here. And then you had grain that would be rotting. So you had some percentage chance every round that maybe some of your grain would rot, or maybe rats would eat some of the grain. And then as they went, they would introduce more and more of these things. So if you're interested in like reading one of the very early design kind of frameworks for a game, hit me up afterwards and I'll give you a link to this thing, because it's actually quite fascinating to read, especially for those of you who are kind of striving to be game designers and not developers. So anyway, let's see here. Where were we? Okay, so the next step was to hand this thing over to this guy called William McKay, who I haven't found any information about, although he was quite important in this thing. But he was the IBM guy, because IBM was supposed to give this this project as much support as they could. And so William McKay was put to work to develop this. And by the way, this is a very important point in the whole mini lecture, which is that these were 2 people who are cooperating in creating this game. And the first person knew absolutely nothing about coding, and the second person knew absolutely nothing about pedagogy, and they decided to come together to create this game, which, by the way, makes this lady up here, Mabel Addis, officially the world's first game designer. And she accidentally is a woman, which is great for the history of development and history of games. But she is, formally known as the very first game developer or game designer in the world. Now, so the game was made in something called Fortran, and I have this little illustration here for you, so you can see how much different Fortran is from like the early types of development or programming languages. So all the way at the left here is binary, which was the way that computers were programmed in the beginning. And then you have this thing called SOAP, which is just this way of transferring binary into something a little bit more understandable. But it's not very understandable. It's pretty impossible to understand, really. And then you have Fortran, all the way to the right. That looks a little bit more understandable. You can see that there's some actual human language in here that lets you write things out. And then you can decide the start of a program and the end of the program, which makes it quite easy. And then you would do as with all of the other seminars that I've had, you would put this into a punch card and you would feed it into a computer, and the computer would understand what to do with it. And here's, by the way, the timeline of some programming languages, and you can see that Fortran was right around 1960, and so it was one of the very, very, very early programming languages. In fact, if you listen to a lot of programming experts who are in their 50s, 60s, 70s right now, they all will kind of reminisce back into the days, not 50s, they wouldn't be 50, but maybe 70s, 80s. Sorry, my math is way off here.
Fun fact is that back in middle 90s, the programming language that would be taught in Russian schools was BASIC, Pascal, and Fortran.
Really? So they taught Fortran in the 90s? Wow.
Yeah.
Well, that's amazing. Well, it is quite...
And not in all schools. In my school, they didn't teach it, for example, but my best friend's school had that.
Okay. Well, I mean, Fortran did develop, so it was, more understandable and easier to work on as the years went by. Just like Python, I think, was made in 1990, but the first version of Python wasn't as great to work with as the Python version that you have today. But yeah. Quick fun fact here as well. It was about 15,000 lines of instructions to make this game. Which is not to say it was the same amount of programming as you would do for 15,000 lines in a modern language, because every line is quite short, but it's still quite a lot. So this just like all the other games that I've been talking about before, pushed the hardware limit to its limit. Now, there's just a few more things that I'd like to talk about, which was the setup, because it's quite interesting what they decided to do with this. At first, they thought they would just use this terminal, and they would talk to this mainframe computer, and this would do all the calculations, and all the gameplay would actually happen on a piece of paper that would be printed out with this electronic typewriter. You would make all the decisions using the keyboards, and the whole game would be just this text up and down. But they tested it out in true game development spirit, and it turned out that people were not very engaged in this thing. It was quite boring. So what they decided to do was to do what all good game developers would do, and they would make some cutscenes, because cutscenes are what keeps people in the cinematic experience, right? So they installed a projector and some audio tapes, so that you could watch movies between the different scenes. And before you even started the game, you would have to watch this 20-minute introduction about Sumeria and what the actual gameplay was going to be about. And kids seem to love this. And just in case you were wondering why people haven't been talking more about this game and why not more people know about it, well, when it was tested out, it was tested out on only 26 primary school kids. So that was all of the people who ever got to play this game during the 3 years they were actually working on this project, which is quite interesting because they run out of money basically. In the end, no one wanted to give this project any more money. So this is how the game looked like. you got the question, and then you would write your answer, and you got a question, and you would write your answer, and then between every round you would get this long printout of the status of your country and what you as a ruler needed to do to improve it. And of course the goal was always to increase the population and increase the amount of grain, and every time you did something stupid, those things would go down. Very, very simple. Now, this game became the inspiration to another game called Hammurabi, which was basically the same game, but with a lot more complexity, a lot more depth to it, and it took much longer to develop it. And this game a lot of people played, and this game a lot of people liked, and that game became kind of the inspiration for most of, or almost all of the strategy games that you play today. It laid the entire foundation, and people know about Hammurabi. Most people who are kind of game development savvies, they know about Hammurabi. But actually, it was the Sumerian game that was the origin story of all of this. Now, I do see that I'm running out of time, so this is going to be the end of the story thing. But I'll just quickly show you, because every time I'm supposed to make a version of this game. And in this case, I severely overestimated my own abilities to create something in a very, very short amount of time. So I thought I was going to be able to, make a full version of this, or at least a partly full version of it. But I didn't, because it turned out I buried myself in a bunch of unnecessary code. So this is all I have. This thing is printing out, and it says, we have harvested 5,000 bushels of grain to take care of 500 people. How much of this grain shall we set aside for the next season's planting? And then you say, maybe 1,234. And then it says, how much will we be stored in the warehouse? The remainder will be given to the people to eat. And you say, 132. And then it prints out a message that doesn't even take into consideration what I just did. But if you look inside of the terminal here, you'll see that there's a new object that got created called God's Wrath, and I'll show you how that came to be. So in the code here, this is the code for the game that I've been working on. You have all these levels that you can add. So you're creating these levels, and then you're putting them all together, and every time you finish a level, let me see here. Yeah, every time you finish a level, you go end round, and then it's gonna go and calculate outcome of round. And here you have this long list of options that can happen. And then every time something happens, it goes okay, it's going to bring locust plague, or it's going to bring God's wrath upon the country and, spite all the humans in there, or it's going to bring a flood or something. And the reason why I have this is because it's kind of a, what do you call it? It's contribution. What's it called when you're take homage? Is that what it's called, Rafid? When you're paying homage to something? Is that what it's called?
Yeah.
Yeah, I'm kind of paying homage to one of the main gameplays that was in the game. And if we go down here in this report that was made, you'll actually see that this exact function has been implemented in the original game. Which, here you go, here it is. So this tree here is the recipe that this game designer put in the report so that the game developer could implement it. And so this here is exactly the same thing as here, and that's why you could see the printout here. It says God's Wrath. So I was very, very unlucky in this round because I got God's Wrath put upon me. And then, if you were a very good developer, which apparently I am not, you would show what God's Wrath is in the output after here and say that, okay, you lost maybe half of your grain, or maybe half of your population died or something like that. But I never got that far because I overestimated myself. So that's something you should consider the next time you try to develop something, is to think, will I be able to do this in 3.5 hours? And if the answer is no, then don't try to do anything silly. So that's the moral of the story.
This is actually a perfect example of Alex making a project and then not finishing, but still being able to present it in a seminar.
Isn't that
Which
perfect?
is exactly what we're supposed to do when the presentations are going to come up in a couple of weeks.
Totally.
By the way, Alexander, I find a solution to your problem.
Which problem?
Which is the pin my tap problem.
Okay.
Oh, okay, great. Thank you so much. Well, thank you for listening. You guys have been incredibly patient. I hope you got something out of this little presentation. And next time, I'm going to be talking about one of the greatest breakthroughs in modern game development history, which is the invention of Pong, which is going to be much easier to implement, which I'm looking forward to. Pong, dun, 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 dun.
That people probably have played
That,
before, right?
I hope so.
Pong.
I hope so.
Yeah.
If not, you need to go back in video game history and do some reading, because it's an important step. First Atari game, by the way, which wasn't actually supposed to be a game. It was just a test for the Atari, but it became one of the most popular games ever in the history of games. Okay, there we go.